Okay, so we've been solving quadratics, and now we're going to solve a cubic equation with the sum and difference of perfect cubes. I don't know if you guys factored sum and difference of cubes or not, but it's really actually pretty simple. It's a pattern, and as long as you follow the pattern, you should have no trouble at all. So the first thing I'm going to do is I'm going to take you through the pattern one time, and I'm going to write down the steps. So writing down the steps is going to take a while. But after I write down the steps, when you go through it yourself, it'll go really quick, I promise. Okay, so the first thing is this only works if these two numbers inside of the cubic are perfect cubes. So you need to know your perfect cubes, at least you need to be able to recognize them. So 8, 27, 64, 125, those are your perfect cubes and so on and so forth. So if you recognize them as being perfect cubes, then that means that this way of factoring is going to work. So, all right, so step one, first thing you're going to do, you're going to factor with two sets of parentheses. One binomial set and one trinomial set. So you'll have a small set of parentheses and then a larger set. So I usually go ahead and write them down and get ready for step number two. All right, you're going to take the cube root of the original terms to fill your binomial set. Same sign as the original problem. So in this case, my original problem is plus. So this is going to be plus. The cube root of x cubed is x. The cube root of 8 is 2. So my binomial ends up being x plus 2. All right, now in order to fill my trinomial set, 3 different things you have to do. First thing I'm going to do is square. You're going to square the first binomial term. So the first binomial term is x. So x squared is going to go there. You're going to multiply the binomial terms. Ignore the sign. X times 2 is 2x. Ignore the sign. So we'll come back and fill that sign in here in just a minute. And then you're going to square the last binomial term. So 2 squared is 4. This time you use the sign. When I square that, it's going to be plus 4. That last term is always going to be a positive because you always get it from squaring the last binomial term. So it's always going to be plus whatever. So the last thing you need to do, this is where we concern ourselves with the sign. You're going to check the signs, and you're going to make sure when you end this that you have 2 pluses and 1 minus. So if I look up here, I have a plus in my binomial and a plus at the end of my trinomial, which means the first sign is going to be a minus. That's just the pattern. It is always that way. You're always going to have 2 pluses and a minus. So if this first one had been a minus and a plus, that would make the first one a plus. So now we are done factoring, but we're not done with the problem because we want to solve this problem. So that means we've got to take each piece and set it equal to 0. So I would take x plus 2, set it equal to 0, x equals negative 2. So remember, the fundamental theorem of algebra says whatever the highest exponent is, that's how many solutions I have. So there should be 3 solutions to this problem. Well, this is one of them. And the other 2 are going to come from this quadratic. So you can solve this quadratic however you want, but I can tell you that it's not going to factor. So you can't factor it. So you're going to have to either do quadratic formula or completing the square. I'm not going to take the time to do that because we've already done that in a video and you've been practicing that. But just know that's where your other 2 solutions are going to come from.